might have results you might not expect. Extra example 2. So according to the Census Bureau, the distribution by ethnic background of the New York City population in a recent year was, and there's the categories, right? So the category is ethnic background, and you fall into one of those categories. There's the percentages. So we would expect then that in a large housing complex that the distribution would be similar to what we expect. So we're going to record data from a sample of 800 residents. And there's the counts. And so we're going to use our chi-square goodness of fit to see how far away what we observe is from what we expect. So first of all, since the large sample size condition is that your expected counts are at least 5, even though your calculator can do this, which I'll show you how to do, you're still going to need to compute your expected counts. So we'll put that right next to this to save us some space. So we're going to have to write, we need to know what we expect, even to get an intuition about is the distribution what we expect, we need to see what they are. So our total we know is 800. That should add up to 800. So what are we expecting for Latino? 224, right? We're just taking a percentage of 800. So here's the percentages. We're just taking that percentage of 800. So African American, we expected 192. White, we expect 280, even though we got 270. And Asian, we expect 96, even though we got 94. And other, we only get 8 here. So it looks like that component might contribute the most to there being a difference. But like Asian looks very similar. So let's see. Why we use chi-square goodness of fit to see how far off we are from what we expect. So let's set up. The H-naught's going to look a little bit different than last time. We're not expecting them all to be the same, but we're expecting the distribution to be this. So we're expecting percentage Latino to be, I'll just use P sub L to equal 28%. So 0.28. And P sub, I'll use AA for African American to be 0.24. Yeah, 0.24. And then percentage of whites to be 0.35. Percentage of Asian to be 0.12 and the other to be 0.01. So that's our null hypothesis. So we assume that's true. What's the likelihood of getting this, of this, what we observe? What's the likelihood of getting this? So our alternative is that one or more of the proportions is not what we expect. So we're going to do a chi-squared. The name of it is chi-squared goodness of fit test. So now we've got more names of different kinds of tests. We have to keep all of them in our mind. The random and independent condition are the same. So let's just focus on the large sample size. Are all of our expected counts greater than equal to 5? We computed them, right? Yeah, even the other. So they're all the expected counts. So you have to find them and show that they are greater than equal to 5. So now let me show you the minimum work to show for chi-squared. You have to show at least the first and last. So observe minus expected squared over expected. And then you can go plus ... This is perfectly fine on any test. Observe minus expected squared over expected. Okay, I'm going to write what you get, and then I'll show you how to do all this on your calculator. So chi-squared 26.06. Let's just think about what the p-value should be. Oh, what are the degrees of freedom? Four, right? 5 minus 1. So the average chi-squared is 4, and we got 26.06. So do you think that's pretty unusual? Yeah. So we're probably going to get a small p-value. So if we compute that, p-value, chi-squared CDF, remember it's always greater than. We want to figure out how unusual. So 26.06 to infinity with 4 degrees of freedom. You have to say how many degrees of freedom because the shape of the distribution is different depending on the degrees of freedom. So you're going to get something with a negative exponent that's going to be pretty small. Anyone have it? 3 point. Thank you. 3.07 times 10 to the negative 5. So really small. Hopefully no one would think that the p-value is 3 because that's like there's a 300% chance of something happening. So be sure that you notice there's a negative exponent. So so since the p-value is less than, we're going to assume alpha is 5%, unless it said that it already said that. Less than alpha, we reject H naught. So the proportions of race distribution were not as we expected. So we could look at the components and see if we think some kind of discrimination is happening.